Okay, closed interval method. For example, the function is like this. Okay. So you want to know what's the global maximum. So global maximum is the biggest point, right? Global minimum is the smallest point across this whole region. Then what's the closed interval method? So there are three kind of points which could be your global maximum and global minimum. First, the easiest is the endpoint. So endpoint, for example, I extend this function like this. Now the endpoint is my global minimum, right? So the endpoint could be your global maximum or global minimum. And second is the point that the derivative is zero. For example, these 2 points, the derivative are zero, right? So the points that the derivative, a point such that the derivative is zero. Okay, for these kind of points, we call them stationary points. Okay, stationary points. And third kind of point is critical point. Sorry, singular point. Singular points are those points where the derivative does not exist. Does not exist. Okay. For example, here, right, you can see this is a V shape. This derivative doesn't exist. This could be your global maximum, right? For example, if the V shape is like this is your global maximum. Okay. So only these three kind of points could be your global maximum or global minimum. So for a given function in a given range, you only have to find all these points and then compare them. Okay. First, fx, problem 8, fx is this. On the interval -2 to 1. Okay. So first, the endpoints. Endpoints is just f -2, right? F -2 subbing, it's 0. Okay. F1 subbing, it's square root of 3. Okay. So second point is stationary point, because stationary point is related to the derivative, so you have to differentiate it first. So if you differentiate, it's 2 square root of 4 minus x squared times -2x. So it's negative x over square root of 4 minus x squared. And now on the interval, right? On the interval, is there any stationary point? Yes, right? A stationary point is when the derivative equals 0. Right? This equals 0, which means the numerator equals 0, which means your x is 0. Right? So this is your stationary point. Okay, this is a stationary point. Then you can calculate what is f0. F0 is square root of 4 minus 0, right? It's 2. Okay. Then is there any singular point? Right? Is there any singular point? You can see this derivative does not exist when x is 2 or -2, right? But we have already considered -2 as your endpoint, right? So we don't have to double count it as a singular point again. So we say that fx derivative exists on the open interval from -2 to 1, right? So there's no singular points. Right? So there's no singular point of fx on the interval -2 to 1. Right? Okay. All right, but we can say f, right, -2 is a singular point. Right? Because when x is -2, this is 4, right? The denominator is 4. It does not, this derivative does not exist. But we have already counted as our endpoints, right? So we don't have to double count it as our single points again. Right, this is a singular point, but it's not on the open interval -2, 1. Okay, so we don't have to consider it. Now, so you have two endpoints, right? You have one stationary point. Okay, then you just have to compare all these three values. Which one is largest? Which one is smallest? Okay, obviously. Right, so now you can make a conclusion. So this one is largest, which means the global maximum. Right, the global maximum is F0 equals 2. Right, the global minimum. The global minimum is, so which one is smallest? This one, right? F -2 equals 0.